Hello, welcome to another IT Wildcard episode. So you probably noticed with these episodes I've sort of dispensed with the episode numbers now because there's a bit of wiggle room in terms of what I talk about with these episodes from this series. Sometimes, like back in the day, it was always about terms and topics, I suppose. Now I'm also talking about my experience of certain courses and just general musings after a lifetime involved in IT and having to learn to a fairly deep level certain domains within information technology. Now, this is the third of this is the third of 3 videos, but yeah, I'm on about the third video, which is riffing around a similar area in terms of a certain, I suppose, writer and educator on coding and programming that I've sort of rediscovered recently, and I'll come on to some of Feline's work at the end again. I think I've mentioned her a couple of times in, like I say, in previous videos. So this is riffing around with some of the stuff that's come off the back of that. Also, someone commented they'd like me to talk about, one of the long-term friends of the channel wanted me to talk about logic errors in a bit more detail when I was, as I've been previously talking about code smells, because it's very tightly associated with that. So that's what I'm going to do about this. Is about the third attempt now of doing this video. The second one since this morning when this video has been recorded, and really due to me just, not feeling it. I had one video where it really just failed at the planning stage. Second video got very rambly, and Bing Chat sort of let me down in terms of some stuff I wanted to illustrate. It was being slow and very non-sticky, if you know what I mean. I used to like it when Bing Chat was or what they're calling it now anyway. They're calling it something different, aren't they? Copilot. When Copilot was being more sticky around subjects, so you'd lock it into a groove and it would happily play along. It's not happening so much. Let me know in the comments if anybody else is noticing that it's not quite as sticky, and you have to be very specific even when you're in the groove and you haven't refreshed about it, keeping it on topic. Yeah, it wants to be going off. So yeah, I'm going to talk a little bit about logic errors, riff around that. So let's see what Wikipedia says about this. So in computer programming, a logic error is a bug in a program that causes it to operate incorrectly, but not terminate abnormally or crash. A logic error produces unintended or undesired output or other behavior, although it may not immediately be recognized as such. So that's the first thing. They tend not to cause crashes a lot of the time. There are some instances, and we'll come on to it, I think, further as we get through this, where possibly you could get a crash as a result of a logic error. But a lot of the time it's one of the reasons why they sort of go undetected. Now, the other reason why I wanted to bring this up is I did notice when I reviewed my episode on code smells, I used the term logic bomb to mean the same thing, and they're not. Logic bombs and logic errors are different things. They're similar, and we'll see why. But this is going to be talking about logic errors most of the time, but I will touch on logic bombs and a couple of really interesting links if you're also interested in that, because they're an interesting subject in and of themselves. So I tend to more associate logic errors with bugs that don't immediately cause crashes. They can occur in compiled or interpreted languages. Yeah, there'd be nothing inherently in either that would make them more likely or less likely to occur, I suppose. But what is more or less likely to occur is the sort of development environment that you might find yourself in. and the language itself as well. So unlike a program with a syntax error, a program with a logic error is a valid program in the language. So it's not a syntax error, it's not a syntax error in the language, but it doesn't behave as intended. So often the only clue of the existence of a logic error is in the production of a wrong solution. But saying that, although, if you run the program, it won't create a syntax error or anything of that nature, static analysis may well spot them. So often, and this is why I got talking about it when I was talking about code smells, a lot of modern linters and other tools which are used to sort of assess your code will pick up the chance of a logic error occurring in the code. So if it's pretty obvious, but a lot of times these go undetected. And it gives an example here of how you might check for them. So one is and there's this sort of old school technique that goes back a long way, which I always used to use, which is, printing out variables onto the screen as you're sort of going through your code to determine the location's error in the code. The location of the error in the code, sorry. Doesn't always work in all cases, and there's other probably better ways of doing that in modern IDEs anyway. You can set all these like points in your program where you can get it to stop and check the variables, but printing out to the screen variables at certain points in a program's execution is a real sort of old school way of detecting certain logical errors, but also other just general mathematical errors. And the example here actually is a sort of a variant or an example of this type of thing, I suppose, to do more with the calculation of something. So here we've got we're calculating the average of two numbers, contains a logical error caused by operator precedence, which we'll get onto in a moment in terms of how deep the rabbit hole goes. But here, and this is pretty common thing. It's one of the reasons why I tend to over parenthesize stuff when I'm programming, just in case. So here you're taking A, adding it to B and dividing by 2. And at least that's what you think it's going to do. However, because of operator precedence, division takes precedence over addition. So it does this first. It does B divided by 2 first and then adds A to it, which is completely different than what it's supposed to do, which is adding A to B and then dividing by 2, because we're doing the average. So we're taking the sum of all of the values, doing that, and then dividing it by the number of values to get the answer. So here we've got just 2 values, so we're dividing by 2. So it's different from a syntax error. I'm not going to go all the way down the rabbit hole in the syntax error, but there's a pretty good example here. So in this particular language, in Java, there should be quotations round, in this case, a piece of text needs to be printed out, hello world. In this case, there's not, so that would cause a syntax error. Now, what you find is, again, you get these weird cases where certain programming languages or integrated development environments, compilers, interpreters may not always pick stuff up because it doesn't necessarily look like an error. So again, you get these, there's disagreement as to what errors a syntax error is. Are they semantic errors? Are they syntax errors? Are they logic errors? Is it because it's problem parsing it? That sort of thing. So yeah, whole combination of things. It also might lead into the whole area of what's called tag soup, because web browsers are lenient in the way they deal with syntax errors. What's the term they used to use? Fail gracefully, I think that was it. And so yeah, I found that actually quite interesting recently when I've been re-exploring HTML and the sort of stuff that you're able to sort of get away with that other parsers might not tolerate. So that leads to a situation called tag soup. But let's look at some of the logical errors that you might come across. So this whole off by one error. Oh, this is really classic. Stems confusion over zero-based numbering. So it's a way in programming of numbering indexes, elements in a sequence, like elements in a list, those sort of things, dictionaries. Depending, I suppose, dictionaries you address differently, but you can. Yeah, it's interesting because there's certain data constructs which can be indexed a variety of different ways, some of which might lead to zero-based numbering issues, some of which don't. So what happens is, if you're dealing with, the first time I came across it was in arrays. So, when I started first learning how to program, the first item in an array had the index of 0, and it works on from that. So because of that, there may be certain circumstances when maybe, I don't know, a good example of this actually I thought of the other day is I'd printed out a list of items, and it was in an array or in a list, and I'd iterated through incrementing, starting off at 0, that was fine, going up to the upper bounds of the list, and so I had the list. So I thought it'd be really nice to add like literally a line number, so 1, 2, 3, to go in front of it. I think it was a list of like 10 bands that I pulled down from an API. And so, of course, when I came to put the line number in front of it, I couldn't just use the variable that I used to increment, like n or whatever, or I, and then put that in front. I had to do I plus 1. So that's not an example of a logic error as such, because it was more of a cosmetic thing to say, okay, I don't want it to say 0, I want it to say increase by 1. But when you get the interaction of two worlds, like how you want it to display on the screen and how you want to count as far as the user is, and how it's counting in a list on the background, when you get a crossover in your functionality where you're going to have to work in both worlds, that's where I find it leads to off by one errors. Also, all these different for loops don't help sometimes. So there's an article here that goes into things like, one-off errors have all sorts of implications, and the trouble is, again, in some environments, it's possible to get numbering errors that don't cause a crash because they're off by one within the bounds of the list. So where you do get a crash is if maybe you've exceeded the number, so you start trying to access an item on a list and the index you're using is above the range of items. So, you're accessing item 8 instead of 7 because there's only 7 items in the list, or vice versa. You may have gone the other way by accident, quite possibly. I think it's more likely to go in the opposite direction, actually, normally. but yeah, so there's that whole one-off byte, and if you do a lot, done a lot of coding in different languages, you may come across instances where you have to rethink, or it comes back to bite you, or you're faced with it again after not really having to think about it because you just instinctively, index everything using zero-based numbering. So yeah. Order of operations, which is what that original example was based on. So yeah, again, tends to come back to bite you if you have experience in programming, if your equations are getting super complicated. I particularly find it when I'm dealing with complications that dealing with equations which are incredibly complicated, and they use repetitive variable names. Like, it might be you've got an equation where one instance you're dividing by a, another time you're multiplying by it, you're adding. I see it a lot, that sort of problem, when I've been working on truth tables and truth tables where they show like false positive and false negative calculations. And there's some quite complicated pattern matching calculations in, say, numerical taxonomy or any form of numerical identification where you're using a sort of variation on a truth table where you're looking at false positives and false negatives and trying to evaluate the goodness of matching, goodness of fit to the match, of an unknown to a known. And those calculations, those pattern matching calculations, can get really complicated, involving, products and sums and roots and reciprocals and instances where you might be, doing factors or squares or roots or all sorts of things. And obviously knowing for the equation and for the language you're working in what is the operator precedence. Now, that's pretty, standardized to some degree. Where it gets complicated is, so a lot of us are used to seeing equations expressed out like this or this. What's interesting is when you get into functional programming, functional programming languages like Clojure and Lisps generally, where they treat equations like a function. So they reorder this so this plus now is placed at the start. I'm going to avoid going down a functional programming rabbit hole in this because that's part of what muddied up and messed up my last attempt at this. But suffice to say, if you're, take a look at Lisp and Clojure if you're interested in seeing a different way of expressing. Oh, here we go. Look, functional and Polish notation. So sort of shrink wrapped into the order of the notation itself. So I try not to click on Polish notation. And tied in with this is obviously arithmetic operators themselves. So the two are closely connected. Order of precedence and arithmetic operators. And just getting muddled, getting yourself muddled up, minusing and plussing, and parts of that extend to things like Boolean logic and various other things, which we'll also get onto. There's also particular problems I find with division, particularly like division of integers, how that's handled in languages. I think particularly where you've got dynamic typing as well, and things like duck typing, where it's making a decision on the way you sort of express certain things as to what the variable might be in terms of its type. And some languages it's more explicit than others, and other languages it's easier to get yourself into trouble with divisions, integers, and yeah, even things like division by 0 that are sort of sitting there waiting to happen, and when you've tested them, the scenario never arises, and then in production it does, just through sheer weight of number and use. And then we get into areas like assignments, defensive programming, things like try, commands in Python, which again I'll avoid going down that rabbit hole because that's something that happened in the other video. But yeah, it's really fascinating, I think, to find as part of the road to getting rid of logic errors is the whole area of what. So when I first started programming, all my defensive programming was, I suppose, proactive to some degree. Well, it would happen. I generally try and detect before the calculation occurred. Now over years, I've been more introduced to commands in the language, syntax in the language that the check actually happens as it's doing the calculation. So it does the calculation, and if it generates an error, it traps it. So except these sort of exception errors and other things you can do to say, at this point in the proceedings, this value must be this, basically, and checking for that. So yeah, so there's a number of different ways you can handle that. You can handle it proactively, as you're processing the value before it gets used in a calculation, or you can trap it when it's used in a calculation. So yeah, and again, this is all really interconnected. The whole thing of variables, how they're used, how they're assigned, whether they're mutable or immutable, even down to things like naming conventions and memory allocation, can all lead a path to a potential for a logic error later on down the line. So yeah, again, I'll include a link to this, and it's a rabbit hole you can go down in your own time. Again, if there is particular things in this episode, this chat, that people would like me to go down, which I'm not currently, let me know and I'll willingly do that. But at the moment I'm going to steel myself so this doesn't turn into another ramble that I then have to scrap. Yeah, Boolean expressions, another great place for logic errors, both in just messing up with your operators, particularly when you're getting very complicated combinations of not, ors and ands and other things. Yeah. There's also a whole load of mathematical symbols like these as well, which I don't think really help. Yeah, like this. I've recently been doing logic as part of a course I'm doing where they were expressing it mathematically, both mathematically and programmatically, and yeah, it can get a little bit confusing when you first see these. It's like, oh yeah, hang on, that's not. Yeah, there's a whole area which I hadn't intended on talking about as well, and this to do the sort of interaction between, that's the best way to put this, between variable declaration and logic, and when you're returning values or processing return values and what type of value they are, and making sure, am I correct in using like empty speech marks over a keyword like none? Those sort of problems. Yeah, so that's a whole thing in of itself. and it goes into a little bit about, and this is just about languages. There's a few, so other things, particularly, I think it happens a lot more when you're comparing, in coding, in programming variables, where you're not seeing the underlying number initially because it's a variable, it's going to change. And often you forget that you really mean greater than, equals, or sometimes my favourite one is when you're working with or and in the process of putting one together, you get these sort of round the wrong way. And again, there's shortcuts in languages where probably they don't help. It can complicate matters a little bit. So there's some tricks you can do in certain languages where you can sort of do a greater than and a less than around a variable in the middle. It's that sort of thing in a if-then statement or some sort of conditional thing like a loop or a for loop or a while loop or whatever. Or even just things like setting up while loops where the condition is never met, so you get this infinite loop, or you haven't included you've deliberately created an infinite while loop, and then you haven't inside of it put a way of breaking out of it, or the way of breaking out of it is never met because of a logic error. So yeah. And then there's other sort of certain keywords which test can be used in evaluations as well, like true, false, and then is it falsity and truthity? Again, it's an area that gets revisited if I think you start to explore closure, the nature of what it means for variables to be true or false, rears its ugly head again. Indentation style. So yeah, that can cause problems. So sometimes it'll get picked up fine in, whatever thing you're using to do debugging or, just using to test code. The way I see it manifest itself is often is to do with it's an indentation issue, but that results are wrong, incorrect in placement within a block. So what I mean by that is, supposing you've got a series of for loops, one after the other, and they're indented, and then there's a certain variable that you might be incrementing, and you've accidentally gone back an indentation point. Happened to me the other day actually when I was doing some code, and of course that fundamentally changes the point at which the variable gets incremented because it's in a slightly different position. It's funny, I never used to have that problem when I coded in BASIC because of for next loops. They actually had a closer. It's basically, so any language where you top and tail the loop or the iterator or whatever you want to call it, so it has a starting point and an ending point. I find those are a little bit easier to spot where you've got indentation issues that might cause logic errors, rather than like an indentation that might cause, say, a syntax error or something like that, or might trigger it, as opposed to iterations that are purely indicated. The scope of the block is purely indicated by the indentation, and so those where that's more likely to happen. In fact, I don't know how many languages now use, you can see here, like this one, we're in what? This would be C style, I suppose. Yeah, that's the other thing. There's like how if you're using like braces to enclose a block. So again, actually, that's quite a good example. I forgot about that. Is using a brace, which is as part of a condition. I find these a lot easier to spot when I've incorrectly indented something, where it's part of, say, like a multiple set of iterators, or if there was like whiles inside whiles or fours inside of fours or whatever. So what I think it is, Kernighan and Ritchie style. Yeah, so there's a whole... I'm trying to think now what I went back to recently. That probably. Yeah. Yeah, that one. And yeah, you can see here it says parts of Python use indentation to determine the structure instead of using braces or keywords. Offside rules. So yeah, it's something just to be mindful of. And again, like I said, it's easier to spot in some languages than others. That's funny. APL style. Wow. Oh, look at all of this. Wow, yeah. So this leads me nicely into something I want to talk about at the end, actually. So actually, let's duplicate that and drag that over, because I forget. Yeah. This is my current obsession, I would say. So now, just compare and contrast this with a logic bomb, which is what I incorrectly called a logic error in my episode on code smells. But this is definitely a rabbit hole I have been down, but many years ago. I have a number of very interesting books on security, malicious software. In fact, there is one book that I've got from way back in 85, 86, I think I bought it, which is, I think it's quite a controversial book at the time because no one had really written about malicious software like that book had. And it covers a lot of ground. It doesn't just look at viruses and worms, it looks at other like malicious acts. And so, yeah, because logic bombs, are used in combination with viruses and worms to execute a payload, or they can be at a predetermined time. But a logic bomb can simply be used to initiate any malicious function, regardless of whether it actually is a virus or a worm, like deletions or changing values, stuff like that. Up till I re-explored this for this episode, most of the examples of logic bombs I'd read about did revolve around disgruntled employees. But it's interesting, I don't think I've seen an example here of the one that I was sort of became aware of and how people got discovered. So a lot of these speak about someone setting up a logic bomb as a result of, where has it gone? Yeah, either just as a result of something else happening. Where is it? I'm trying to now find it because where are we? Change code on the server. Self to go on his birthday. Yeah, so yeah, sorry, this one here. So as a result of being terminated from a job, that's really the sort of ones I was most familiar with. There's a whole load of other interesting scenarios here which either are riffs on that or just people being outwardly malicious, or even this one as well. I'll come on to this in a moment, which is pretty interesting. Yeah, because it has lots of implications for things. But yeah, so this one where someone actually loaded a logic bomb in after. The whole point of using a logic bomb in these examples is it goes off way after the person may have left, or that sort of thing, so that they don't necessarily realise who did it. I mean, of course, the problem is if you get any good person who's good at like computer forensics in, they should be able to find, I suppose, as long as there's source code around that they can do it. I mean, you can reverse, what do they call it? Decompile. I'm trying to think of the correct term here, but where you take compiled code and like convert it back. Yeah, so that is a problem. In what were they thinking in terms of getting away with this? The examples that I'd seen actually originally, which were based around this, people would set like almost like a dead man's handle, where they would set something up that they'd have to periodically remember to change or to do, and that way, if they were removed from their job, at some point, they wouldn't have updated the thing, so then it goes off. And that's probably where I most came across it, and how those often got uncovered is the person got sick or an accident happened and they went on holiday, or they went on longer from in the period where they were supposed to have done the refresh, the thing that sort of stopped the logic bomb from being triggered by a certain file being on a certain server or something like that, and then it went off, or someone was temporarily drawn in and they were poking around in the system and they were thinking, what the hell does this file do? Why is this here? And then they sort of trace back. Although it's not based on logic bombs, one of the most fascinating books I've ever read on someone sort of effectively working through a system that they didn't create is the book The Cuckoo's Egg. Yeah, very famous book. It's one of the first books I read when I got interested in security and sort of malicious actions and hacking, but way back in the 80s. So yeah, with the early sort of days of the internet before it became available to the general public, I suppose. So yeah, sort of pre mid 80s, I think. So yeah, that's a good. I'll make sure I won't do it now, but I'll include a link to the Wikipedia article about the book. But this one here I'd not heard of before. So there's connections between this and right to repair, I suppose. So 2023 researchers discovered that some NEWAG trains were secretly programmed to deliberately break down after a certain distance, or during maintenance windows, or when onboard GPS confirmed that they were located in rivals' workshops for repairs. Wow. So I'll link to this article, and it's sort of name checks the right to repair story around the John Deere tractors, where they locked them down, and so there's parallels with that. But it was, done in, I suppose, well, I must admit I don't know the ins and outs of this, but this appears to be a little bit more like nefarious and not quite so visible, not quite so much transparency, but I could be wrong. Like I said, I'm not familiar with what went on here. I know little bits about this, I remember at the time. So I'll include that. And this I brought up one of those previous ones under here and include a link to that, because this was actually in a spreadsheet. And this was the one, I don't know if you saw it, I probably skipped over it, where it was done deliberately to ensure that they hired the contractor to fix the bugs. So they were creating these bugs which wouldn't normally be detected because they weren't syntax errors. But by making them logic bombs, they would sort of go off and, the person would come back and fix them. Now, I've again heard of similar things where people who are involved in troubleshooting have sort of done some things deliberately to create themselves more work over a period of time by doing various nefarious things, some of which involves logic bombs, but just other general unpleasantness. But it's interesting. I didn't realise until I brought this up just before I did the episode that it was inside of a spreadsheet, which does lead very interestingly, and that wasn't planned, into something else I'm going to be talking about at the end, and last week's previous one. The previous episode I did under this series. So I brought this up here because I wanted to remind myself of something. So something I've become really interested in. I've turned in, full confession here, I've turned into a bit of a Feline Herman's fanboy. So I've just recently revisited her stuff and then reminded myself how awesome this person is in terms of the things she sort of talks about, stuff that really interests me. So she's got a book out. I don't receive any. There's no link. I won't include any links. There's no what do they call them? There's no associate links in my in here for this. So I'll leave it up to anybody watching this that is interested in this sort of stuff. So we'll look here and let's look inside so then you know exactly what this is about. So on reading code better, on thinking about code, on writing better code, and on collaborating code. But what's interesting, I think, is when I've seen her do certain talks, is she does talk an awful lot about code smells, the sort of art of code, the shape of code, things like that, and, which I thought was cool, and I didn't realise till literally just before I recorded this as I scrolled through, there's actually a piece of BASIC, which is what I started programming in. So look, there's for and next. So I'm seriously thinking about getting hold of this book. I'll have to either put it on a birthday list or a Christmas list, probably a birthday list, because that'll be first. But it touches on so many things that fascinate me in just writing good code. But if you watch my other videos, the other area that she's really interested in is this idea of spreadsheets of code, which I fully endorse. It's funny, if I prototype, I'll often, and to stop me making annoying errors with calculations, I'll sometimes run through them in a spreadsheet. Or the first question I ask whenever I'm going to do anything is, can I do this in a spreadsheet? If I'm trying to solve a problem, can I do this in a spreadsheet? And then the second one is, should I do this in a spreadsheet as well? It's cool. It's got a bit of a. It's here. Yeah, I think I need to own this book. I was tempted to basically sign up to like a subscription with Manning for a little bit of time, because it's one of the subscription services for computer books which I haven't tried. I've tried O'Reilly. I had it for about a year actually. It's pretty expensive, and I only had it when I was doing a lot of or looking at lots of different systems, and it was worth my while. Now not so much really. There's so many good books out there actually that are now what do they call it, sort of Creative Commons as well, which if you want to you can buy in print, but they're available on the website. The Rust book's a good example of that. Like if you want to learn Rust and you want the Rust programming language book, you can actually just go to the website there and access it. But I just chose to buy the physical book because, yeah, I like physical books. Or, I've got a number of programming ebooks as well. And another thing to watch out for, I don't think it would ever necessarily end up there, is the service Humble Bundle. If you don't mind ebooks. But yeah, it's a very interesting thing. I'm definitely starting to re-examine or go back down a sort of programming, like psychology of programming stroke philosophy of programming rabbit hole domain. Like, thinking about coding and the issues of complex code. And the reason why I did this is because it does have connections with how code lays out, how you look at it, but also this thing I think I've mentioned before, which I like to sort of get my head around, is when you're working in different languages, what languages, when you look at them, immediately you go, I know exactly what that is. So that sort of thing. So code comprehension, the whole idea of heuristics, pattern matching, rule of thumbs for looking at stuff. I don't think I mentioned this in this particular video because I've done 2 attempts of this, so it could have been I think it was in one of the other ones. But sort of in closing, one thing that I've done a lot of over the years is people often ask me how the hell, when I'm doing training in different packages, do I know where things are? And my arguments, my answer is always the same. Is I said, well, if you were to ask me verbally, like, explain where, the print, that's probably too easy, but, what menu such and such is on Word. If you were just to ask me that, I probably couldn't answer. But if I'm sitting in front of a computer, and it's also, I suppose that there's a muscle memory element to it as well. But if I'm sitting in front of a computer and I'm really sort of into the structure, physically I'm engaged with it, I'll click through pretty quick and find whatever it is that I'm looking for. Just because a lot of it's just unconscious, but also there's certain heuristics where I'm just going, okay, it's probably going to be in this tab. I'm not thinking that consciously, but that's what I'm doing. I'm sort of, just scanning the ribbon and just clicking in the place where I just know instinctively it's going to be. But if you were to ask me, what ribbon, what tab is so-and-so on in Excel, like I don't know. I'm trying to think like the Czech equation. I probably couldn't tell you off the top of my head, but as soon as I'm sitting in front of that computer and I'm seeing the tabs, I just know sort of where to go on there. And also it's really helpful when you're maybe in a application that you're not familiar with, but it's in a similar domain, like another spreadsheet program or another word processor or things like that, or a different browser maybe. I notice now things are getting a little bit blurry again, unfortunately, with stuff, in terms of some programs mix it up a little bit. But, and to me, that's all mixed in with this idea of learning patterns in things, in domains that you work in. Like, what are the underlying structures? What are the patterns? What are the heuristics? What are the idioms of a particular thing? Like people talk, in Python about things being Pythonic. What are the cool ways of doing things, the preferred ways of doing things in a particular domain as well. Like I'd not thought about like coding standards for a long while, until recently, when I started using style analysis programs and things like that. And it sort of brought back to me the importance of sort of knowing those sort of things. So to me, this is all sort of interrelated. And the other thing I wanted to mention is, I think one of her areas which she's really interested in as well is to do, funnily enough, with spreadsheets. And I mean, it would detect logic bombs, I'm assuming, but this whole idea of and I haven't seen the research for it, so it might be purely anecdotal. But this idea is that the sheer amount of money that's been lost in businesses to spreadsheet errors, and whether or not that actually exceeds the amount of money that's lost through programming errors in other things apart from, because as I said, if you think of spreadsheets as code, but if you take spreadsheets and you take everything else that's not a spreadsheet that you can sort of program or do calculations in, on a computer, mainly, or programming languages generally. Maybe, more money's been lost through mistakes in spreadsheets. And part of that is because, a large percentage of the use of spreadsheets is in financials. And I suppose one of the best things that ever happened to me, best and worst things happened because it was probably the most stressful period in my life, was when I had to program account systems. It put me into a whole other area. It's like next level programming for me anyway, just because of all the things that can go wrong and all the stuff that can break, and when it does break, how expensive it can get. So I think I'll close on that note, on a cheery note. If you want to explore the whole area of logic errors, don't get involved in doing logic bombs. Just do it purely for preventative measures to protect yourself against them, logic bombs. But logic errors, you definitely play around with calculations and financials and stuff like that to really see what can go wrong, like rounding errors, those sort of areas. Fascinating way of teaching yourself more about how you can sort of prevent errors in programming. So thanks once again for watching and listening. Hopefully that wasn't too rambly. Bye for now, and I will catch you in a future episode.